So we're going to analyze and sketch the graph. So we're going to have to find our vertical, horizontal isotope, our max, min, and points of reflection. And I need to make sure that I label them. So first I'm going to try to find vertical and horizontal isotope. So the vertical isotope, I'm going to set the denominator equal to 0. So x equals -1 is a vertical isotope. To find the horizontal isotope, I'm going to set the limit as x goes to infinity. So this is similar to x over x, highest power in the denominator, highest power in the numerator. So I get 1. So y equals to 1 is the vertical isotope. So if I kind of sketch it, okay, since my vertical isotope is x equals to -1, that means at -1, I'm going to have a vertical isotope, and y equals to 1, I'm going to have a horizontal isotope. Okay, since so now I'm going to find the maximum. To find the maximum, I have to take the derivative. So to take the derivative, I'm going to find, use the quotient rule. So u is x minus 1, v is x plus 1. The derivative of u is 1. The derivative of v is 1. So the derivative is going to be the derivative of u times v minus the derivative of v times u all over v squared. We're going to set that equal to 0. So if we cross multiply, we end up with x plus 1 minus x plus 1 equals to 0. Okay. So notice that I have nothing, the x cancel. So the only critical point that I have is when x is equal to -1. So notice when x is equal to -1 is my critical point. So I'm going to do a little number line. So remember, I'm checking the derivative. So I need a number to the left, -1. So let's try -2. So if I substitute -2 into here, okay, I get -1. Substitute -2 into here, I get -3. And then the denominator is always going to be positive because it's squared. So this is going to give me a positive number. So let me substitute 0. So again, I'm going to have 0. So that's going to give you 1 times -1. So that's going to give me a positive as well. So that tells me that my function is increasing from -infinity to infinity. Okay, so it's increasing from -infinity to infinity. So it's probably going to look, see how it's increasing? Okay, that's increasing. So another thing that I'm going to check is I'm going to check for my points of inflection. So to find my points of inflection, I'm going to go ahead and take the second derivative. Okay, so here's my derivative. So I'm going to take my second derivative. I'm going to rewrite this as 2x plus 1 to the -2. So the second derivative would be -4x plus 1 times the derivative of the inside. And then I'm subtracting 1, so I get -3. Okay. So once again, if I solve this, notice how everything's going to cancel out. So the only critical point that I have is when x is equal to -1. And I'm going to check my second derivative. So to the left, I'm going to try -2 So negative 2 plus 1 would be negative 3 to the third power. That would be a negative, and a negative divided by negative would give me a positive. I put 0 here. I got 1, 3, so that's positive. So a negative divided by a positive would give me a negative. So that means that my function is concave up here, concave down there. So back to my function. So notice that it's concave up, concave down, just like we had concave up, concave down. So my sketch is going to look like that. I'm not going to have any points of inflection because, okay, so I have no points of inflection, and I have no max or min. Okay, so there's no max or min. Because notice this goes from positive to positive. So there's my graph.